Hi guys, we're going to start chapter 10. I'm going to try it without my sunglasses this time. Let's see if you can try not to make fun of me. Okay, lesson 10.1, exploring quadratic graphs. The objective of this lesson is that you're going to be able to identify qualities of quadratic graphs and graph those quadratic functions. To begin with, we would like you to take these vocabulary terms, look in your book, and find the definitions of these. These need to be included in your notes for full credit on your notes. Our first term is a quadratic function, standard form of a quadratic function, quadratic parent function, and these are all quite similar, a parabola, the axis of symmetry, and then finally the vertex. And you need to discuss or come up with the definition for the minimum and the maximum. Let's talk about minimum and maximum. This refers to your vertex. And so if you look at this equation, y equals ax squared, this gives you quite a bit of information. It gives you the vertex. The vertex right here is 2, -4, but we know that our parabola opens upward because our a value is positive. It's greater than 0. And so because it opens upward, this vertex is at the bottom, it is a minimum parabola. If I gave you y equals -ax squared, it's the same as this except it opens up in the opposite direction. It opens downward. And you knew this because your a is less than 0. Your vertex is up here, and its coordinate is 1, 2. And it is a maximum because your vertex is higher than the rest of your parabola. Let's try these two. If you want to pause and figure out whether they're minimum or maximum, you can do that. This vertex is right here. The coordinate for it is 1, -2. And it is a minimum because it is at the bottom of the parabola and it opens upward. Figure out the coordinate of your vertex here. It is -2, 4. And then it is a maximum because it opens downward and it's at the top of your parabola. Okay, we're going to try graphing a quadratic function. Our first one is y equals 1/2 x squared. If you want to draw this graph and then draw this table, 0, 2, and 4 are the 3 terms that we are going to use for x. So how do you graph this? Well, you plug your 0 in for x. When I plug in 0 for x, 0 squared is 0 times 1/2 is 0. Plug in 2. 2 squared is 4 times 1/2 is 2. And then finally, 4 squared is 16. Half of that is 8. And all you have to do is graph those 3 points. Once you graph those 3 points, now you're going to move these points across the y-axis in the exact same position, but on the negative side. So it was on +2 here, it's on -2 directly across. It was on +4 here, it's going to be on -4 here. And now we connect our dots. Make sure that you do this in a U shape, not in a V, as some students want to do. A parabola is curved, and it should look like that. So I'm going to put the next one up on the screen. I would like you to try it on your own and see if you can figure out how to graph it. We have the function of x is 1.5 x squared. The 3 terms that I want you to use for x are 0, 1, and 2. Now would be a good time for you to pause the video. Okay, if you're back, when we plug in 0, 0 squared is 0 times 1.5 is 0. We're going to plug in 1 for x. We've got 1 squared, which is 1, times 1.5 is 1.5. And then 2 squared is 4, times 1.5 is 6. You do the exact same thing. You graph those 3 points. Then you translate those across the y-axis in the exact same position, but on the negative side. And you connect your points. Pretty easy. Try another one. Pause and see if you can figure this one out. Remember, if a is less than 0, what happens to your parabola? I want you to use these 3 points again for x, 0, 1, and 2. Okay, so we're going to plug in 0 for x. 0 squared is 0 times negative 2 is 0. 1 squared is 1 times negative 2 is negative 2. And 2 squared is 4 times negative 2 is negative 8. We are going to graph those 3 points. You'll notice they are below the x-axis. And now we're still going to move those across the y-axis to get our other points on the other side. If you had taken the opposite of these two terms, negative 1 and negative 2, you would have gotten these coordinates right here, but it's much less work if you just move them across the y-axis. Connect your points, make sure it's curved. Okay, the parent function, y equals x squared, would look like that. It starts at the origin. Your a value is a positive 1, so we know that it opens upward. Y equals 4x squared. It still opens upward because it's a positive number. It looks like that. And then our final one we're going to look at is y equals 1/4 x squared, still pointing upward. How do the coefficients affect the width of your parabola? Take a moment and look at that and see if you can figure it out. Hopefully you figured out it's an inverse relationship. The larger your coefficient, the smaller the opening of your parabola. Again, the larger the coefficient, the smaller your opening for your parabola. Let's look at a negative one. If I gave you y equals negative 4x squared, you all should know by now which direction that's going to face. Correct, it's going to face downward. It's going to look like that. And the thing that you'll notice is this blue parabola was positive 4x squared. Our pink parabola is negative 4x squared. It doesn't affect the width of the parabola. If it's negative or positive, it's going to be the same. It's just the direction that it opens up. So negative does not matter. Let's try putting these three, the first set, in order from the widest to the narrowest. These 3 functions. Remember, the larger the coefficient, the narrower your graph. Okay, so what is, since it's the largest coefficient equals the narrower graph, then we're going to look for the smallest coefficient to be our widest graph. And so what is our smallest coefficient? 1/3 x squared. Our next one is 1, and then finally 5. See if you can do these second set of functions. When we put those in order, we get negative 2/3 x squared, then negative 2, and then negative 4. Hopefully you were able to do that with some ease. Okay, graphing y equals ax squared plus c. So we're adding our c value. Y equals x squared looks like that. Y equals x squared plus 2. What do you think that's going to do to our parabola? It's going to move it up 2 spaces. Y equals x squared minus 5. Well, if plus 2 moved it up 2 spaces, then what do you think negative 5 is going to do? Good job. It's going to move it down 5 spots. So how does the c affect the graph? Hopefully you were able to figure out that the c translates the graph up or down. C is also your y-intercept. Okay, and finally, a gravity problem. A monkey drops an orange from a branch 26 feet above the ground. The force of gravity causes the orange to fall towards Earth, and the function is h equals negative 16t squared plus 26, which gives you the height of the orange, h, in feet after t seconds. I want you to graph this quadratic function. I'm going to give you a little preliminary information. First, our table will look like this, and you're going to use 0, 1, and 2. The height depends on the time. And finally, your graph is going to look like this. Try to figure this out before class. Have a good day.